Hi everyone, in this video we will be talking about divide and conquer. Let me tell you what it is. So divide and conquer is a way to solve problems. In the realm of CS, when we have a problem, divide and conquer, say for example problem 1, divide and conquer would mean trying to divide this problem into sub-problems, so P1A, P1B, P1C, and then the intuition is once we solve these smaller problems, you just combine them together, and the combination of those small solutions would solve the bigger problem too. So say for instance, let me try to give you an example. Suppose, so this is our sample problem. Suppose we have a piece of land there, and the measurements of the piece of land is 16. Let me change this. Whoop. The measurements are 1680 by 640. The problem that we have, and this is the problem of Euclid several centuries ago, was that I want to divide this land into equal parts. What is the measurement that would allow me to divide this land into equal parts while at the same time maintaining that I get the biggest possible land area that I have? Let us break that problem down into a smaller problem so that we are clear. Say for instance, I have a 4 by 2 landmass, so it's 4 by 2. If I try to divide it into equal parts, we can say that, hey, just divide it into 1 by 1 components. That way you have 8 1 by 1 boxes, and then you have 8, so you have 8 1 by 1 boxes. You have divided the land equally, while at the same time you have a total of 8, so that's a lot. However, what Euclid wanted was, yes, great, that equally divides it, but also notice that there is a 2 by 2 square that would divide the 4 by 2 land equally, and 2 by 2 is the biggest possible sub landmass that would divide the whole landmass equally. So even though you only have 2 components or two parts here, but you were able to maximize the landmass per individual land. And if I'm able to understand the history, this has been a problem because they had they needed to divide the land equally among members, because inequality in giving out land actually led people back then to kill each other. So they must ensure that the piece of land would be divided equally, and that the piece of land that they give out would be significantly large. Hence the problem. Can we divide it into what's the measurement that could divide this landmass into equal parts while ensuring that everyone gets the biggest possible landmass for themselves? So how do we solve this? Let's go back to our problem here. What if the landmass is not anymore 4 by 2? What if it's 1680 by 640? Divide and conquer would tell us that the first thing you need to do is to find a base case. So find, or let me offer a better what works for me better, reduce this problem into a base case, meaning what is the simplest possible form of this particular problem where we can find a solution. So say for example, a 1 by 1 landmass cannot be the base case, because we technically cannot divide it. For the scope of this problem, let's say that we don't want a 0.05 by 0.05 landmass, so that cannot be the base case. What's the next possible best simplest thing? Perhaps a 2 by 1 landmass. I think now we have some sort of workable base case, because if we divide this into 2 parts, we have A and B, that are equal. Both of them are 1 by 1, 1 by 1. And so what properties can we retrieve from this? You might say, so what, Nate? Okay, we have 2 by 1, we divided into two parts. Now what? Well, notice that this is special because unlike a 3 by 1, unlike a 3 by 1 landmass, if I divide it here, say for example, I attempt to divide this 3 by 1 landmass, I don't solve the problem immediately. I don't solve it. And base cases have the property where when you are given something, when you are given the problem, one step would actually solve it already. And for this particular example, putting a line in between the 2 by 1 landmass would already solve our problem for us. So that is the base case. Now you might say, okay, how can this help us? Well, we can describe what the base case is, and for purposes of demo and to so that this video is fast, notice that A is a multiple of B, meaning if you try to multiply something to B, you eventually get A perfectly, not A point something something, not the decimal point representation of A. So our base case seems to be A should be a multiple of B. Alright, now how can that help us? Well, we say that if that's the thing, if that's what we're after, perhaps we can reduce these initial measurements, continuously reduce them such that they arrive at the base case where some measurement is the multiple of the other, and then once that's done, we know that whatever this value is that divides this one perfectly, then that's going to be the measurement that's the largest possible square, measurement of the square that would ensure we have a lot of max possible number of squares while maintaining that the landmass is adequately large, or the largest too. So let's try to do that. If I try to go back to our example, how will this look like? So we know that there's a 1680 by 640 square. It's here. Largest possible square, this is 640, that's my 1680. If I have another 640 here and I do it again here, that leaves me with an extra, and that extra is 400. Now what I have after the first iteration is a square that looks like this. That's the thing that whatever the extra is the thing that we continuously reduce. So here I have a 400 by 640 square. So this is 400, this is 640. I would have to try and divide this again. So 400, that's 400 by 400, this new square that I have an excess of, this is 240. So essentially, if I try to rewrite that again, I have 400 by 240. So this is this is the 400 part, this is the 240 part. Now I can repeat the process again, because why am I not stopping? Because 400 is not a multiple of 240, or 240 is not yet a multiple of 400, which is why we have the excess. If we try to create a box out of this to check for multiplicity, if there are multiples, to check if there are multiples, then I end up with a measurement of, or an excess of 160. This one, the excess is 160. Let me draw it a little bit larger than the scale so that I can label it correctly. This is my 160, this is my 240. So I have in my 1, 2, 3, third iteration, I have a 160 by 240 measurement. If I try to create another box here to create a 160 by 160, then this particular excess measures to be 80. Now, let me draw this again to scale so that I can label the parts correctly. I end up with an 80 by 160 cube. Sorry, 80 by 160 landmass, which if we try to examine, 80 already perfectly divides 160, similar to what we have here. And so, in our last iteration, where we get a measurement of 160 and 80, when we are able to reduce the problem to the properties of the base case, then we can safely conclude that this particular number here, the number that divides one of the others perfectly, is now the measurement that we can use to divide the whole problem evenly. So we can safely say that, friends, 80, if you have an 80 by 80 square, you won't have the trouble of being killed by your people, because everyone would get equal number of boxes, and we are mathematically sure, you can tell them that you can prove it, that that's the biggest possible land that you can possibly give. If you give more than that, then it skews up the evenness. If you give less than that, then you might find some even values, but the landmass is not anymore significantly big that you will enjoy them. So this is divide and conquer. You're trying to establish a base case that would represent your problem, and at each recursive step, which is why we discussed recursion first, at each recursive step, you're trying to make your problem be a little bit closer to the base case. Once you run into the base case, then you would already have your answer. This varies for problems, but for this particular problem, but the thinking is the same. You have a base case, reduce your problem to that base case, and you should be able to find the answer. The challenge is on the design. How can you represent this problem in terms of a base case? And that is something that you pick up the more that you're exposed to problems. So that is divide and conquer. In the next video, I hope to discuss quicksort. So see you in the next video. Thank you for watching.